Long before jaws existed, before bones hardened into familiar shapes, before predators chased prey with speed and precision, there was a different rulebook for survival. In that ancient world, simplicity was not a disadvantage. It was dominance. The lamprey is a survivor from that era, a creature whose body reflects a time when evolution was still experimenting with the fundamentals of vertebrate life. At first glance, the lamprey barely resembles a fish. Its body is elongated and eel-like, smooth and flexible, lacking scales, paired fins, or jaws. Instead of a mouth built for biting or tearing, it possesses a circular suction disc lined with concentric rows of sharp, keratinized teeth. At the center of this disc sits a rasping tongue, capable of grinding through flesh. This design is not accidental or grotesque. It is ancient, and it works. The lamprey's anatomy represents one of the earliest solutions to feeding in a world where complex skeletal structures had not yet evolved. Without jaws, the lamprey does not chase prey in the conventional sense. It attaches. Once contact is made, suction seals the mouth against the host's body, and the tongue begins its work. Blood and bodily fluids are drawn out, often mixed with anticoagulants secreted by the lamprey to keep the flow uninterrupted. The host may survive. Sometimes it does not. This parasitic strategy has earned lampreys a fearsome reputation, but it is also a testament to evolutionary efficiency. The lamprey does not need to kill to succeed. It needs only to persist. Feeding sessions can last hours or even days, during which the lamprey remains attached, expending minimal energy while extracting maximum nutritional value. In evolutionary terms, this is not cruelty. It is optimization. Respiration in lampreys is equally unconventional. They breathe through a series of small openings along the sides of their body rather than through a single gill cover. This allows them to continue breathing even while attached to a host, a critical adaptation for a parasitic lifestyle. Oxygen flows in, carbon dioxide flows out. The system never pauses. The skeleton of the lamprey tells another story of antiquity. It is composed primarily of cartilage rather than bone, a feature shared with sharks but rooted even deeper in evolutionary time. This lightweight, flexible structure allows the lamprey to move with fluid precision, navigating rivers, ocean depths, and narrow spaces with ease. Strength here is not rigidity, but adaptability. Lampreys occupy both freshwater and marine environments, depending on species and life stage. Many begin life in rivers, spending years as larvae buried in sediment, filtering microscopic food particles from the water. During this phase, they are harmless, almost invisible, contributing quietly to nutrient cycling and sediment health. Only later do they transform, undergoing a dramatic metamorphosis that equips them for a parasitic adult life. This transformation is not gradual. It is radical. Eyes develop, teeth form, the digestive system restructures, behavior shifts entirely. A passive filter feeder becomes an active parasite. Few vertebrates undergo such a complete functional redefinition within a single lifetime. The lamprey does not just grow up. It becomes something else. Movement during adulthood is purposeful and efficient. Lampreys swim with undulating motions that mirror the earliest vertebrate locomotion patterns. They are not fast sprinters, but they are relentless travelers. Some species migrate long distances between freshwater spawning grounds and marine feeding areas, navigating currents using environmental cues that remain poorly understood. The journeys connect ecosystems separated by vast spatial and chemical boundaries. Reproduction closes the lamprey's life cycle with the same ancient logic. After returning to freshwater, adults spawn in gravel beds, releasing eggs and sperm externally. There is no parental care. Energy is fully expended. For many species, spawning is the final act. Death follows shortly after. Nutrients return to the ecosystem that sustained them. Life ends not with retreat, but with contribution. The lamprey's ecological role is deeply paradoxical. As parasites, they weaken or kill individual hosts. As a species, they regulate populations, remove weaker individuals, and recycle energy across ecosystems. In systems where they evolved naturally, they are not invaders. They are balance agents. Understanding the lamprey requires abandoning modern moral frameworks. It is not evil. It is not malicious. It is ancient. It follows rules written long before humans assigned value judgments to nature. Its success is measured not in popularity, but in persistence. And persistence is something the lamprey has mastered better than almost any vertebrate alive. The true strangeness of the lamprey does not begin with its teeth or its parasitic feeding. It begins earlier, hidden beneath riverbeds where light barely penetrates and time seems to slow. Here, lamprey larvae live for years in a form so different from the adult that they were once mistaken for an entirely separate species. Buried in soft sediment, these larvae filter microscopic particles from the water, feeding quietly, almost passively, as rivers flow above them unaware. This larval phase can last anywhere from 3 to 7 years, sometimes longer. During this time, the lamprey poses no threat to any animal. It has no teeth, no interest in flesh, no parasitic intent. Instead, it functions as a living filter, improving water clarity and recycling nutrients within the ecosystem. In this state, the lamprey is not feared. It is invisible, and invisibility is often the most effective survival strategy of all. Metamorphosis changes everything. When environmental cues align, body chemistry shifts, and the larva begins a transformation that borders on the extreme. Eyes emerge. The mouth reshapes into the iconic suction disc. Teeth form where none existed before. Internal organs reorganize, prioritizing feeding efficiency over digestion complexity. What was once a sediment-bound filter feeder becomes a mobile, predatory parasite. Few vertebrates undergo such a total redefinition of purpose within a single lifetime. This dual existence reveals something profound about the lamprey's evolutionary logic. It does not commit to one ecological role. It occupies multiple, sequential niches, extracting value from each without competing with itself. As larvae, lampreys contribute to ecosystem stability. As adults, they regulate populations and redistribute energy. This is not inefficiency. It is optimization across time. The parasitic phase, though often vilified, is not random or indiscriminate. Lampreys do not attach to the first host they encounter. They respond to chemical signals in the water, identifying suitable species based on size, health, and availability. The goal is survival, not destruction. Hosts that survive an encounter often carry scars, evidence of a transaction rather than a kill. In natural systems, this interaction rarely leads to collapse. It leads to balance. Behaviorally, lampreys display a focus that feels almost mechanical. Once attached, they enter a state of persistence, minimizing movement, conserving energy, and maintaining attachment through suction rather than force. The secretion of anticoagulants is a critical adaptation, preventing blood from clotting and ensuring continuous feeding. This chemical warfare is precise, not excessive. Enough to sustain, not enough to waste. Despite their primitive appearance, lampreys are highly sensitive to environmental conditions. Water chemistry, temperature, and flow all influence behavior and migration. Many species rely on pheromones released by larvae to locate suitable spawning rivers, a communication system that spans life stages and generations. Rivers become living archives of chemical memory, guiding adults back to environments that once sustained them. Social interaction among lampreys is limited but not non-existent. During spawning, individuals cooperate to move stones and gravel, creating nests known as reds. This collective behavior suggests a level of coordination rarely associated with such ancient animals. It is not social bonding in the mammalian sense, but functional cooperation driven by shared evolutionary programming. The lamprey's place in food webs is complex. As parasites, they weaken hosts, making them more vulnerable to predators. As prey, lampreys themselves feed birds, mammals, and larger fish. Their larvae are consumed by invertebrates and fish alike. Energy flows through them in both directions, making them conduits rather than endpoints. Human perception often strips this complexity away. The lamprey's appearance triggers discomfort, and its feeding strategy invites moral judgment. Yet ecosystems do not operate on aesthetics or ethics. They operate on balance. Where lampreys evolved naturally, their removal often leads to unexpected consequences, including overpopulation of certain fish species and altered nutrient cycles. Understanding lampreys requires confronting a deeper truth about nature. Survival does not require refinement toward what humans consider progress. It requires adequacy. The lamprey is adequate in a way few organisms are. It does not need to evolve rapidly because it already fits. And that fit has allowed it to persist while countless more advanced forms have vanished. The conflict between humans and lampreys is not rooted in ancient history, but in geography. In ecosystems where lampreys evolved naturally, their presence is woven into balance. But when they appear outside those systems, the rules change. Nowhere is this more evident than in large freshwater basins where lampreys arrived without the predators, competitors, and environmental checks that once kept them in equilibrium. When lampreys enter such systems, their efficiency becomes overwhelming. Hosts that never co-evolved with parasitic attachment lack defenses. Populations decline rapidly. Commercial fisheries collapse. What was once an ancient survivor becomes labeled a monster, an invader, a biological error that must be corrected. Control programs emerge, designed not to understand, but to eliminate. Chemical treatments are applied to rivers to kill larvae buried in sediment. Barriers are built to prevent migration. Traps are deployed to intercept adults before spawning. From a management perspective, these strategies work. Lamprey numbers fall, fish stocks recover, economies stabilize. From an evolutionary perspective, something far more complex is happening. A lineage that survived mass extinctions is now being selectively erased from regions it never asked to enter. This creates an ethical fracture that conservation biology still struggles to resolve. Can a species be both a vital component of nature and an unacceptable threat, depending entirely on context? The lamprey forces that question into the open. In native habitats, it is protected. In invaded systems, it is targeted relentlessly. The same animal, two moral identities. Even within native ranges, perception shaped policy. Lampreys do not inspire affection. They lack charisma. They do not fit conservation narratives built around beauty or rarity. Yet removing them alters food webs in subtle but measurable ways. Host species populations swell beyond sustainable limits. Disease dynamics change. Nutrient transfer between marine and freshwater systems weakens as migratory lampreys disappear. The irony is unavoidable. Humans value ecosystem balance, yet often seek to remove the very mechanisms that maintain it because they are uncomfortable to observe. The lamprey does not hide its method. It exposes it, and exposure invites judgment. Climate change adds another layer of uncertainty. Altered water temperatures shift spawning cues. Flow regimes change. Some lamprey species expand their range. Others retreat. Management strategies designed for stable conditions begin to fail. Control becomes more expensive, less predictable, and ethically murkier. The line between native and invasive blurs as ecosystems themselves transform. Despite intense pressure, lampreys persist. Their life cycle remains flexible. Larvae endure in sediment where control methods cannot always reach. Adults navigate obstacles with determination honed by deep time. Total eradication proves nearly impossible. And perhaps that is the point. The lamprey was never meant to be easily removed. It was shaped to endure disruption. In studying human responses to lampreys, scientists gain insight not only into ecology, but into ourselves. Which species we choose to protect reveals our values. Which we choose to destroy reveals our fears. The lamprey occupies the uncomfortable space between those choices. It is ancient, effective, and indifferent to opinion. The lamprey is often described as a living fossil, a phrase that suggests stagnation, as if time passed it by and forgot to take it along. But this interpretation misses the point entirely. The lamprey did not survive by resisting change. It survived by arriving early at a design so functional that change became unnecessary. While countless lineages experimented, specialized, and collapsed, the lamprey remained adequate. And in evolution, adequacy sustained over deep time is not mediocrity. It is mastery. To call the lamprey primitive is to misunderstand evolution itself. Evolution does not move toward improvement. It moves toward fit. The lamprey fits. Its jawless mouth, parasitic feeding, cartilaginous skeleton, and dual life cycle are not half-formed steps toward something better. They are complete solutions to ancient problems that still exist today. Food must be acquired. Energy must be conserved. Reproduction must occur. The lamprey solves these problems with ruthless efficiency. There is a philosophical discomfort in confronting such a creature. Humans tend to associate progress with complexity, beauty with value, and dominance with success. The lamprey challenges all three. It is simple, unsettling, and indifferent to perception. Yet it has outlasted creatures that were faster, larger, and more elaborate. Its survival undermines the narrative that evolution favors what looks advanced. The lamprey also exposes the illusion of control. For centuries, humans believed rivers could be engineered without consequence. That ecosystems could be rearranged, simplified, optimized. The lamprey's persistence reveals the limits of that belief. Control programs reduce numbers, but they do not erase lineage. Barriers slow migration, but do not end it. Chemical treatments kill larvae, but not the evolutionary logic that produced them. In native ecosystems, the lamprey remains a quiet architect of balance. In invaded systems, it becomes a mirror reflecting the consequences of ecological disruption. In both cases, it forces a reckoning. The question is not whether the lamprey belongs. The question is how ecosystems respond when ancient relationships are broken and replaced with human intention. The lamprey does not adapt to human values. It adapts to water chemistry, current flow, and biological opportunity. It does not recognize borders, labels, or management zones. It follows gradients, pheromones, and ancient cues encoded in its nervous system. In doing so, it reminds us that nature does not negotiate. It responds. As climate shifts accelerate, the lamprey's future remains uncertain, but not fragile. Uncertainty is not new to this lineage. It survived ice ages, mass extinctions, and planetary upheaval long before humans arrived. Whether it survives the Anthropocene will depend less on its own capacity and more on how much ecological complexity remains intact. If the lamprey disappears from places where it evolved naturally, the loss will not announce itself loudly. There will be no silence to notice, no iconic absence. Instead, rivers will behave slightly differently. Fish populations will fluctuate in unfamiliar ways. Nutrient flows will change. Balance will tilt, subtly at first, then decisively. In the end, the lamprey's lesson is not about parasitism or primitiveness. It is about endurance without apology. About survival that does not seek approval. About life that persists not because it is loved, but because it works. The lamprey does not ask to be understood. It only continues.